Hey everybody, Omnigriffin here, and welcome to Human Resource Machine. So, this is made by the same people as Little Inferno, that is Tomorrow Corporation. This game is on sale, or was on sale, for the Christmas sale, so I went ahead and picked it up. I figured, new year, new games. Just a quick run through, maybe an episode of each game, just to see how people like them. And maybe continuing back and coming back and seeing how things are. I enjoyed Little Inferno so much that even though this game seems, to me, like it'll be easy, I still want to give it a shot, because Little Inferno is arguably really easy, short of figuring out some of the combos. So the whole idea is that Human Resource Machine... Oh! Whoopsie. That's the power button. Don't worry about that. I needed to click on things that weren't that. This is totally me. That photo looks just like you. I am Employee 1. So, we are going to learn all about this game at the same time, basically. You're going to learn exactly as I do. So, we start out in the mailroom. This is the Human Resource Machine. So, this is our first day. You look like an excellent instruction follower. I am not. I haven't played Stanley Parable on my channel yet, so I guess I can't prove that one way. Your first job will appear over there on the right side in a moment. Remember, you can always ask me for help. Drag commands into this area to build a program. Your program should tell your worker to grab each thing from the inbox and drop it into the outbox. Ah, I see. Okay. Right. Okay. So the only difference here is that I should have done this. So this is exactly what I thought it was going to be, and that is a programming simulator game. And not even simulator, it's a programming game. We are going to be given more and more commands that allow us to do things. So we take from the inbox, we place in the outbox, we take from the inbox, we place in the outbox, we take from the inbox, we place in the outbox. Now the thing that's missing in here is that this is storing it in our human resource machine, that is us, and then it is output into the output. I know that seems minimal, but so if I haven't been over this in the past, my profession is software engineer. That's why I think this game is going to be easy. I program for a living, and I'm now programming as part of my hobby. So, awesome. That's why I think this is going to be easy for me to wrap my head around conceptually. So if you are not familiar with programming in any way, it may seem like I'm making weird leaps or something like that. I don't know how it's going to play out yet since we're still doing puzzles. But, see, here we go. We've now been given a new command. Grab each thing from the inbox, drop each one into the outbox. You get a new command. You can drag a jump's arrow to different lines within your program. With this new ability, you can complete this assignment using only 3 total commands. Yep. It's a good hint. Jump is a go-to. So, whenever you're reading like an instruction manual, say, for putting something together, it'll say, step 1, do this, step 2, do this, step 3, do this. And occasionally you run into things where say, if you have this product, go to, you can skip to step 7 or skip to step 9, whichever. That's what jump is. Jump is a go do this step. So step 1 is take from the inbox. Step 2 is place in the outbox, exactly like we did before. Now the difference is we now add a jump, and this jump says go back to here, which is step 1. And by executing this, inbox to outbox, and then it jumps there and starts over. And now we can always speed this up. We know that this is correct. Boost sequence is what it's spelled. Awesome. That's really cool. I actually like that. And that arrow right there, very beautiful for showing this conceptually. Showing what the program is actually doing. This is really cool. I really like this already. But this is gonna be, oh, this is gonna be weird. Okay, the inbox conveyor system is completely broken, but that doesn't mean we get to take a break. Okay, so now we've got copy from. Ignore the inbox for now and just send the 3 following letters to the outbox. B-U-G. Bug. Go figure. The facilities management staff has placed some items over there on a carpet for you. If only there were a way you could pick them up. Alright, so I think we take from the inbox, we copy from 4, we move to the outbox, so here's the thing. This isn't going to be easy because this isn't something that we can do. So we go take from the inbox, we copy from 0, take to the outbox. So we can't actually use jump here, which is unfortunate because this loop, this is a loop in which we are doing the same 3 things over and over, but we have one thing that's changing. If we had an easy way to know which of those we wanted, we could do this. Now, I'm also assuming that the inbox thing is correct. Okay, yeah, we have to copy. That's what I thought. And as you can see, this is working exactly as I tried to describe. Puzzle complete. This is very much a puzzle game, which honestly I wasn't entirely expecting. Oh, cool. We have fixed our conveyor system. Beautiful. So, just in time for it to see to work, the data won't collate itself. Okay. New problem. And now we have a copy 2. Interesting. Grab the first 2 things from the inbox and drop them in the outbox in the reverse order. Repeat until the inbox is empty. You get to, okay, so what this is saying is instead of putting 4 then 5, we want to take 4, take 5, place 5, place 4, but we can't do that. So we're going to take from the inbox, we're going to copy to 0. We're going to take from the inbox, put that in the outbox, take from the inbox again, copy from 0, and then we're going to take to the outbox. Now, what this does is we'll take the 4, we'll put it in 0, we'll take the 5, put it in, take the next thing, which doesn't matter, copy from 0, which is our 4, and then place that in the inbox, which will effectively do what we want. There is a slight weirdness here, but I think this should work. Okay. Interesting. So, the difference here is we were supposed to do everything. And we didn't. We're supposed to have 6 things. Supposed to have 6 things. So we can't throw out the 4. We threw out the 4. That's not what we want to do. So here's the question. Here's where we get to learn how to do stuff. So we want all this gone. I want to know. So I know that this is right. So can I take from the inbox again? Okay, that does that. The problem here is I'm trying to understand how all of these things function. So if we take from the inbox, we throw out what we currently have, but we need all 6 things to make it to the outbox. but we need to drop them in the outbox in the reverse order. That repeat. Oh, grab the first two things in the inbox, drop them in the outbox in reverse order, repeat until the inbox is empty. So basically, we're going to have a jump that repeats this because we need to put in 91FC91. 91FC91. That's how we have to do this. So there's going to be a jump that goes all the way back to the start and does it again. The problem is we can't do this. How do I preserve that? Can you give me an example? Okay, that's what I thought. First things second, second things first. Things happening in and out of order is a constant source of anxiety in my life. Did we already talk about this? Maybe we already did. Okay, here's something that I'm not... Okay, you need to stop talking. So we're going to copy that to 0. We're going to take the inbox, put it to the outbox, and then we're going to copy from 0 and put that in the outbox. I wonder if that'll work. So we throw that out. That's the thing that's bad. We take that to the output. Can I just copy from this? Yes. Okay. We're good. This will work. I was not aware that we could just pull straight from there. But as you can see, this loop is now functioning exactly as expected. And I now know that we don't have to have anything in our hands to be able to pull from memory. Because that is in fact what those boxes are, memory. At my parents' house there is a dog. Hello, how are you doing? Yeah, I'm recording stuff. Oh, we have a cutscene.
Back to work, everyone.
Yep, back to work. Newsflash.
Regions of the city continue to experience power failure. Local authorities are investigating.
Power failure is not a good thing, and I have a feeling it's going to play into our next puzzle. Ooh, career milestone 1. We got an achievement. You guys can't see it. Okay, so we're going to have a choice to make here at some point. Welcome to my personal rain cloud. I was never very good at math, since I have 3 fingers on each hand. Yeah, I can see that. But I hear you don't actually need to know much math to complete these assignments. For each 2 things in the inbox, add them together, and then put the result in the outbox. You got a new command. It adds the contents of a tile on the floor to whatever value you're currently holding. Okay, so now we are going to take from the inbox. We're going to copy to 0. We're going to take from the inbox. We're going to add 0 to it and put it to the outbox. Does that all make sense? I hope so. So we're going to take 3. So just to step through this, we take 3. We copy it to 0. We take 4. We add it to 0, which gives us 7, and then we put that to the outbox. And that works. And we're just going to keep doing that until it's done. I imagine that eventually this jump is going to have a conditional on it. That's a fun animation. And we're just going to keep going. But yes, these boxes on the floor, this is... And the input and output could be a number of different things, but very specifically in this case, this green box is your computer's memory. And it is actually rather clever. I'm liking the way that this game is. This game is a very good teaching tool, I think. I don't think it's very useful to me, so I'll go the one that has an end route. Who are you? This optional area is for high-performing employees only. Is that you? Well, you're late. 7 years late. I need to make some changes around here. I want to see 100% performance increase. From this point on, your performance will be evaluated with extra scrutiny. For each thing in the inbox, triple it. Okay, so we're going to take the inbox. We're going to copy it to 0. Then we're going to add 0. Add 0. Take to the outbox. So this adds it, puts it in the output. This is effectively multiplication. In the grand scheme of things, it's just not as important. This, of course, is going to end up as 0, but... Now, how are they going to measure this? I wonder if it's actually going to 6 or fewer commands. Ah, I see. Interesting. Okay, these challenges are difficult and in many cases not possible. So, these challenges are all about your algorithm. So the algorithm is what we built. We built an algorithm to triple whatever we have in memory. Now, obviously, in a real programming language, you just need to multiply by 3. We're not really worried about that. This is a specific, very specific language. It's one that's developed for this. We're not going to see anything, in my guess, we're not going to see anything that particularly resembles any specific computer language, except assembly. And that's where this gets fun. And I'll get back to that. I think that's a little bit too high level to go into right now. There's like a total huge thing that I could start talking about it like mad. Alright. Yes, you can always check your own performance on each assignment's optimization challenge. 2 green lights next to each button will tell you how you're doing. Alright, so for each thing in the inbox, multiply it by 8. So this is going to be fun. So obviously this is where we're going to build. This is, or not inbox, outbox. This is what it's eventually going to look like. So we're going to copy 2, 0, storing what we have in memory. And then we're going to add 0. Now here's where it's going to get a little bit interesting. We could do this 8 times. We could do it 8 times. But that's not very efficient. So doing this multiplies it by 2. Doing this multiplies it by another 2. And we'll watch this happen. We'll watch it happen. So we've multiplied by 2, we've multiplied by 2. So we've multiplied by 4. So we just need to do it one last time. So what'll happen is, we'll take the 3, we'll store the 3, we'll add the 3, make it 6, multiplied by 2. We store the 6, we then add the 6, making it 12. So we multiply the 3 by 4. Now, I'm actually going to go ahead and do this. This won't actually change anything in terms of what we get from the output, but it'll make it more visible how things have gone. I don't think it'll hurt our performance. Multiplied by 8. And you can see the progression. Times 2, times 4, times 8. Now, the fun thing here... Yep. Oh, I totally missed that they even say you can do it using 3 add commands. But that's how. Check. Boom. See? Beautiful. we'll go ahead and do the tetra content. Alright, multiply it by 40. So multiplying by 40 is going to be a little bit different. A little bit different. And luckily they've given us 1 so that we can see. So we're going to start with a jump. We've built our loop. Conceptually, this is how I'd go about doing it. We want to loop through everything, so we're going to have a loop. Take something from the inbox, put it to the outbox. What do we do in the intro? So if we obviously need to go ahead and immediately copy it to 0. To multiply by 40, we're multiplying by 8 and multiplying by 5. Because the whole copy thing that we did before from memory, that is basically a way to multiply by 2. We can't multiply by 2 and get any, a specific number of times and get 40. Doesn't quite work that way. However, we can do something kind of shenanigans. It's not that great, but it could be worse. So we'll go ahead and do this. That goes ahead and that multiplies it by 2. So that'll be 2. And then we're going to do this a couple ways. So this will be multiplying it by 4. So we go 1. Now it's 2. We put 2 and 0. We add 2. Now I'm going to copy this to 1. Oops. Actually, I'm going to go ahead and copy this to 1. Add 1. Copy to 2. There's a reason for this. It's not great, but there's a reason for it. So we now have 1 and 0, 2, and 4. So then we take 4, which isn't 2, so that we've now multiplied by 4, and we add, oopsie, I keep clicking off that. We add 2, which gets us 8. We copy that to, oopsie, to 1. There's a reason for this. It's to get around the shenanigans if we can only multiply by 2, and it'll make sense here in a second. I'm trying to think of the right way to explain it, but it's not quite working. We add 1, so now that's 8, that's 16. There's a better way of doing this. There's a better way of doing this. I'm doing it slightly wrong. Once I started saying the numbers out loud, I started realizing. So we have 1 and 0, we have 2 and 1, we have 4 and 2. We then have 8 in our hands. We copy 8 to 2. We then add 2, which gets us 16. We then copy to 1, so we've got 16 in there. Then we add 1, which has 16 in it. We get 32. And then we add, oopsie, 2, which has 8 in it, which should get us 40. This is a little bit more convoluted than I was hoping for. So 1, 2, 4, 8, 16, 32, 40. We successfully multiplied by 40. This is very convoluted, but the easiest way to break down 40 into multiples of 2 was 32. Multiples of 2 isn't quite right. Powers of 2. So 2 to the first is 2, 2 squared is 4, then 8, 16, 32, 64. 32 is the biggest that we can do. So we do 32, and then we do 8, which is 14. By adding those powers of 2 together, we get things properly. It takes a little bit more commands. I'm curious to see if we actually got they're ideal or not. Oh, nice. Perfect. Well, that's pretty sweet. Now we're going back to the easy stuff, presumably, or probably new commands. Your performance will be evaluated with extra scrutiny. Okay, so we're getting the commands from here as well. Send all things that are not 0 to the outbox. You get a new command. It jumps only if your value is 0. Otherwise, it continues to the next line. So jump if 0. This is where fun stuff happens. Okay, so we know that we are going to do this for everything. We're going to take from the inbox, and we're going to jump to the outbox. But we're doing a jump if 0. So if it's 0, we want to take the next thing from the inbox. We don't want to take it from the outbox. We just want to throw it away. So this should work. Is it a 0? Yes, go to the outbox. Is it a 0? Well, we jump to taking something from the inbox. And there you go. Plain and simple. Now this is a little bit different than how if statements normally work. But it works out. We used 4 commands. 23 steps. Sounds good. We're burning right through these, and it's almost time to call the episode. It has come to our attention that the Zero advocacy community felt the previous assignment was not inclusive. This time send only the zeros to the outbox. What happens to the other numbers and letters? Management leaves that details up to you. Okay. So, once again, but the thing is, so I'm not sure if this is exactly what they're going for, but the way that this is going to work is we're going to take something inbox. If it's 0, we're going to skip this jump and then go to the outbox. If it isn't 0, we'll hit this jump, which takes us back to the inbox. This is a little bit more how normal if statements work, but it seems a little bit more odd to see it drawn out, at least for me, like this. It's kind of throwing a wrench into the way I think about things, which is definitely neat, don't get me wrong, but oh man, it feels so weird. There are ways to get this concept through in most code. Ooh. Interesting. I wonder if I actually can. Make it 25 steps. So I had 3 extra steps. Interesting. So how do we go about doing this? To make it go faster. So I had the right number of commands. It's just... Isn't this what I had, though? The order in which these occur doesn't actually matter. Now I kind of want to know. How do I optimize this faster? So... commands per fewer is better. So here's the real question. So the optimizations, and there's that asterisk that says, you know, if you do it in the right number of commands, if you do it in the fastest number of commands, you do better. So here's the thing. There's an annoying... I think they're trying to teach a lesson here. I'm going to see if I'm correct here. That's the -2. So D 0 0. I don't remember all the input. Inbox, inbox, outbox. Okay. Glorious failure, solution not robust is the achievement that we just got. So I'm going to stop here for this episode, but not before I explain this. When looking at the efficiency of an algorithm, a couple things come to a head, basically, when you're trying to do this. First and foremost is if you had basically an arguably infinite number of solutions, or just a very large number, how would it perform? And how would that performance change versus a small number? This is a relatively complicated description. It ends up mostly having to deal with exponentials, logarithms, and things like that, depending on how your algorithm works. But even before that is whether or not it works for different inputs. So one of the things that I was curious about is what would happen if I directly programmed this. So knowing the input string, I could know the output string. This is something that does not work, and that is why I'm getting yelled at by my boss here. Because it's not something that you can do. You can never perfectly predict what input you're going to get. If you do, there's really no reason to even have that input. So obviously in this situation, as they say, he can give me a solution that my algorithm does not correctly solve for, therefore it is not a useful algorithm. So what they're asking for in their optimizations are amount of code and amount of time. The first optimization is how many commands? Well, 5 commands works. 5 commands is the fewest commands you can use to get it done. That means that if you were writing this in actual code, that would be the fewest lines of code that you have written, which is a good thing in a lot of cases. You don't want a lot of code. But there's also a solution here that they're talking about that takes less computational time, less number of instructions executed, which makes it technically faster. So my short code solution is actually a longer execution time solution by 3 instructions. Now, I'm going to look in probably next episode because I'm already loving this game, and yes, it's a little silly, but I love the way that it's being presented with the person, the employee, me being the processor, and the inputs just being on conveyor belts. It's fun. I'm actually enjoying it quite a bit. So, we'll go ahead and stop and reset. Regardless, this is pretty fun. I can't help but... Oh gosh. It says send only the zeros. If it said send only zeros, I would just wait until the first 0 and just keep copying it. Anyway, we'll look into this into the next episode, but hopefully you understand why this output of commands is not useful. It does what it needs to do for this specific set, but no other set. And in fact, he did. In fact, he said he was going to give me a set of inputs that would break my algorithm, and it does. That's fantastic. Okay, I am already in love with this game. I love it. I think I'm going to do more episodes on it. Let me know what you guys think in the comments section down below. Do you like this game? Do you like me talking about this? I wasn't expecting to be giving programming lessons on my YouTube channel, because that's not at all what this was for, but it's just funnily taking a twist like this, because the Tomorrow Corporation, they get me, I guess. So, I will see you guys next time, but until then, keep your gears turning.